Hi, class. We are now discussing direct. Yesterday we discussed direct. Okay, excuse me. Today we are discussing inverse variation. Okay, and let's try and position our screen a little better here. Okay, all right. We established that an inverse variation is when one variable is going up, the other variable is going down. That's an inverse, okay? And so therefore, we have an equation for inverse operation, equation y equals k over x, okay? Wherein we notice that our x is in the denominator, okay? Whereas with direct variation, our x is not in the denominator, it is actually a whole number or in the numerator technically, okay? So let's take a look. We are going to start with numbers 4 through 14. It asks us to identify if it's direct, inverse, or neither. Let's start here with number 4. Just in pure comparison of this equation to this equation, we see that our x is in the denominator. Our numerator is a whole number, okay? It's not 0, all right? And so this is equal to y. Therefore, just by looking, we can determine that this will be considered inverse. So we're going to put an I there for inverse variation, all right? Here, we do not have a value or an equation equal to y. So we would need to isolate y to make a informed decision about whether this is direct, inverse, or neither. So let's take a look. If we isolate y in this case, we're going to add x to both sides, and therefore y is going to be equal to x. Okay, so if y is going to be equal to x because 0 plus x is x, in a case like this, can we determine that there's a coefficient next to x? And that answer would be yes, because it's always understood that there's a 1 there, okay? This x is not in the denominator. It is a whole x, or in the numerator for technical purposes. So therefore, we would establish or make a conclusion that this can be in this form. Therefore, this is direct. Okay? Now, when we take a look here, we have a situation where x is in the denominator, but y is not isolated. So we need to isolate y. And so at this point, y is being divided by 3. So what we want to do is multiply 3 to both sides, okay? And therefore, we will have y, I'm just going to erase this, but we're multiplying to both sides, 3 here, 3 here, okay? And therefore, y is equal to 6x. And therefore, for number 8, when we compare our final equation, we make the determination that number 8 is an inverse operation. Okay, let's look at number 10. On number 10, we need to isolate y. So we need to put 9 to both sides. And so therefore, minus 9, minus 9. So our final equation looks like this. X minus 9 equals y. And therefore, we can conclude that it's not direct, it's not inverse. So therefore, it is neither. Okay, here on number 12, we notice that y is isolated. We also notice that x is in the denominator, and therefore we have a whole number that is greater than 0 in the numerator. So we make the conclusion that this comparison is an inverse operation. Okay. On number 14, we need to isolate y. We find that y is here in the numerator. Therefore, it being divided by 4, we're going to multiply this by 4. We're going to multiply this by 4. And once we do that, we conclude that this is 20x, okay, equal to y. Okay, so now we notice that number one, we have isolated the y. We also notice that x is in our numerator, and we also notice that in our 3 is in our in my denominator, but we are focusing on the x. And in this case, this can be written in this form. And you may say, well, how is that possible? Well, it's possible because it can be written like this. Okay? All right. And so therefore, since that it can be done that way, then we make the conclusion that this is a direct variation. Okay? All right. Let's take a look here. Here, the textbook says that this is an error. The error reads thusly. It says, describe and correct the error, telling whether x or y show inverse variation. So in this case, we can't use this equation as it is to make a determination because y is not isolated. So we need to isolate the y. And therefore, instead of dividing by 2, we're going to multiply by 2. And that will cancel out the 2 so that y will be equal to, in this case, 16 over x. And so therefore, we can say, yes, based on this equation, we have the inverse. All right? So this would be an inverse, all right, operation. Okay? Now, on the next section, we will be graphing. Okay? We will be graphing our coordinates, and in graphing our coordinates, we will make a determination about the data to determine if it's inverse or direct. Okay, let's start with number 18. Okay, we are counting by halves here, and we have a half here, so we're going to count by halves, and our highest x is at 11. And our highest y is at 8. So that's what we're going to do. We're going to count by halves. Let's move this. Let's get started here. We have no negative numbers. Okay. So you know what? We're going to do this. All right, so this would be 0, 0. This would be a half. This would be 1. This would be a half, 2, half, 3, 4, 5, 6, 7, 8. And so that's as high as we're going to go with the y. Let's look at our x. 0, half, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're going to assume this is 11. Okay? All right, so let's check out the first one. On the first one, we're going to use blue. It says a half x, okay? 6, half x and 6. Then it says 1 whole, 3. Then it says 3, 6. So 3, 1, my fault. 3, 1. And then 6, a half. All right, so let's try it again. Let's verify. A half, 6. Got that. 1, 3. Got that. 3, 1. 3, 1. Got that. And then we have 6, half. Got that. Okay, so now let's connect our dots. If we go like this, just by looking at it, we can make a determination that this is showing us inverse. Okay, this is inverse. Okay, simply because as x increases, y decreases. Okay, or as x decreases, y increases. Okay, so we have a yin yang type situation here. All right, so now we're going to move on to the next one. And our next one, we are looking at number 20. I need to move a little faster. Time is running out. We have 2, 1.5. We have 4, 3. We have 8, 6, and we have 11, 8.25. Okay, so now we can see that our line is straight. Question is, does it go through the origin? Well, let's see. Let's get our slope. Our rise is 1.5, and our run is 1, 2. So let's drop 1.5 and 1, 2. So yes, it hits the 0, goes straight through 0, 0. So this will be direct. All right, I need to hustle. All right, the number y of miles driven and the number x of gasoline of gas used are related by the equation y equals 2x, okay, for 2x.5, 28.5x. And so the question is for number 22 is to tell whether it's direct or inverse. Because it's here, it's direct, okay? The x, you have a direct variation, all right? It does not, x is not in the denominator. Okay, let's take a look now at 24. On number 24, our last equation, it asks us to determine, write the inverse equation for this problem. They told us that we have a set of coordinates that are 2, 6. All right, and they told us that this is the inverse. We can look at it, it is inverse. So we take our inverse equation, and we have the coordinates, our x and our y. So we plug in our x and our y into the equation, y being 6, x being 2. Then we must solve for k. So that means we need to isolate k. Instead of dividing k by 2, we're going to multiply by 2. And therefore, 2 times 6 is 12 is equal to k. Once we know what k is, now we rewrite the original equation in an inverse variation form. And that is, it is written y is equal to, we plug in our k, 12, and then we put our x. Well, what that means is we can determine where we are on the line every time we plug in an x using this formula. So we must know what the inverse variation is. In this case, it is 12. So then we can plug in any value for x and determine where we are on the line, or plug in any value for y and determine what x is, okay? So if we plug in an x, we get the y. If we plug in the y, we plug in the x based on this equation right here, because we made the determination that based on this location, that the inverse variation is 12, okay? So that's how we use that, work with inverse variations. Therefore, we have concluded the lesson. Hopefully, you have a better understanding of inverse variations, and I'll see you on tomorrow. Have a good evening.